DevOps, Development and Operations, is a set of practices aimed at automating and integrating the processes between software development and IT operations. It enables faster development, testing, and deployment of software with enhanced collaboration and continuous delivery. Here's a complete guide to the DevOps structure. 1. What is DevOps? DevOps integrates development, dev, and operations, ops, teams to improve collaboration and productivity by automating infrastructure, workflows, and continuously measuring application performance. It focuses on shortening the system development lifecycle and providing continuous delivery with high software quality. 2. Core principles of DevOps. DevOps is based on several core principles. Collaboration breaks down silos between development, QA, and operations teams. Automation automates repetitive tasks such as testing, integration, and deployment. Continuous integration, CI. Developers frequently merge code changes into a shared repository. Continuous delivery, CD. Ensures that code is always ready to be deployed. Monitoring and feedback loops. Monitoring applications in production to identify issues early and provide rapid feedback. 3. DevOps lifecycle. The DevOps lifecycle is a circular process that includes several stages. 1. Planning. Defining business objectives, requirements, and project roadmaps. 2. Coding. Developers write the software code. 3. Building. The code is compiled and packaged into an artifact, e.g., a.jar file. 4. Testing. Automated tests ensure code quality, identifying bugs early. 5. Releasing. After testing, the code is deployed into staging or production. 6. Deploying. Continuous deployment pipelines are used to push code into production environments. 7. Operating. The software is monitored in a production environment to ensure performance, availability, and security. 8. Monitoring. Gather and analyze data to detect and respond to problems and improve future releases. Key components of DevOps structure. 4.1. Automation tools. Automation is a key part of DevOps. Several tools are used to automate each stage of the lifecycle. Source control. Git, GitHub, GitLab, Bitbucket. Build automation. Jenkins, Travis CI, Circle CI, Bamboo configuration management. Ansible, Chef, Puppet. Containerization. Docker, Kubernetes infrastructure as code. IAC. Terraform, AWS. CloudFormation monitoring. Prometheus, Ok, Grafana, Way, Aina. ELK. Stack, Elasticsearch, Logstash, Kibana. Splunk testing. Selenium, Junit, TestNG. 4.2. CI/CD. Pipeline, continuous integration, CI. Regular merging of code changes to a central repository and automatic testing. Continuous delivery, CD. Automatic deployment of code changes to staging and production environments. CI/CD pipelines typically involve 1. Code. Commit. Developers commit code to version control. 2. Automated build. The system automatically builds the new version of the software. 3. Automated testing. Test suites are run to verify code quality. 4. Deployment. The code is automatically deployed to staging production. 4.3. Microservices architecture. Microservices breaks applications into small independent services that can be deployed and scaled separately. Service mesh. Tools like Istio or Linkerd that help in managing microservices and controlling how they interact. Mabta 4.4. Containers and orchestration Docker. A containerization platform that packages applications into portable containers. Kubernetes. A platform that automates container deployment, scaling, and management across clusters of hosts. Number 4.5. Monitoring and feedback. Monitoring tools ensure the health of the system and provide feedback to the DevOps team. This feedback loop is essential to improve both applications and processes. Application Performance Monitoring, APM. Tools like New Relic, Dynatrace, and AppDynamics. Log aggregation. Tools like LK-Stack help in analyzing logs for troubleshooting. 5. DevOps Team Structure. A typical DevOps team is cross-functional, integrating members from both development and operations. DevOps Engineer handles infrastructure, automates processes, and manages CI/CD pipelines. Developers write and test code. QA test engineers ensure the code quality by writing and running automated tests. Operations T manages production environments and infrastructure. Security Engineer integrates security practices in CI/CD pipelines. DevSecOps. Out of 6. Popular DevOps tools. Here's a list of popular DevOps tools, categorized by function. Category Tool Source Control Git, GitHub, Bitbucket, GitLab CI/CD, Jenkins, Travis CI, Circle CI, GitLab CI, Containerization Docker, Kubernetes IAC, Infrastructure, Terraform, AWS, CloudFormation, Monitoring Prometheus, Grafana, Nagios TE, ELK, Stack Automation Ansible, Chef, Puppet 7, DevOps Best Practices Version Control. Use Git for version control of both code and infrastructure with tools like Terraform. Automated testing. Automate testing at multiple stages of the pipeline. Continuous delivery. Ensure that every change can be deployed to production quickly. Infrastructure as code. ANUM, IAC. Treat infrastructure configuration and provisioning as a code, making it easier to automate. Security integration, DevSecOps. Integrate security checks into CI/CD pipelines. Frequent monitoring. Implement real-time monitoring of applications to identify issues as early as possible. 8. Challenges in DevOps implementation. Cultural shift. Encouraging collaboration between traditionally siloed teams. Security. Ensuring that security checks do not slow down development cycles. Tooling overload. Managing a complex set of tools and integrating them effectively. Skill gaps. Bridging the gap between development and operations skill sets. 9. Emerging trends in DevOps. DevSecOps. Integrating security practices into the DevOps pipeline from the beginning. AIOps. Using artificial intelligence to automate operations, particularly in monitoring and log analysis. Serverless architecture. Reducing the complexity of managing infrastructure by using serverless technologies like AWS, Lambda, or Azure Functions. 10. How to implement DevOps. 1. Assess current capabilities. Evaluate the current development and operations processes. 2. Adopt the right tools. Choose automation and collaboration tools that fit your organization. 3. Start small. Begin by automating simple processes and gradually scale DevOps practices. 4. Focus on culture. Foster a culture of collaboration between dev and ops teams. 5. Build CI/CD pipelines. Automate integration, testing, and deployment processes. Measure success. Use metrics like deployment frequency, lead time for changes, and mean time to recovery, MTTR, to measure the impact of DevOps. By following this guide, organizations can successfully adopt DevOps practices, leading to faster software releases, better collaboration, and improved system reliability.